In this video, we're going to apply a /8 subnet mask to the same address that we've used with the /24 and the /16 and see how that changes the size of the network that's available. And you can see here now the gold numbers are taking over and the red numbers are becoming scarce. Whereas in a /24, most of the address was red. It was mostly network. In this case with the /8, it is mostly gold or mostly host. So if we look at our network size now, our network is now just 8 digits. 8 out of the 32 digits will be applied for the network. So any number that starts with, when I say any number, any IP address that starts with 192 is going to be in the same network with a /8. So if it starts with 192, it's in the same network. Great. This is a huge, huge network, right? I'm not even going to add it up, but we can see that you've got a whole bunch of digits over here on to the right that are applied with zeros in the mask. And if they're applied to zeros in the mask, it means it's part of the host. It means any combination of 0 and 1 in the IP address would be considered as part of the same network. The bit order that needs to be the same is just right here, and that's it, because those first 8 bits determine the size of that network. All right, fantastic. Let's very quickly just kind of go through this and identify the network ID value and then the broadcast ID value. And those are the two addresses that, remember, you cannot use for hosts. Can't use a network ID or broadcast ID for a host. And then you can figure out how to come up with the total number of digits or total number of addresses that are in this particular system. It's a lot. All right, so we've got 8 digits. We've got 24 digits total for host. So anything that starts with 192 is going to be in that same network, and the total number of hosts is going to be 2 to the 8th power plus 2 to the 8th power plus 2 to the 8th power, which equals 2 to the 24th power, which is a really, really big number. If there's another way that we can get to that, 2 to the 8th power every time is 256, so it's 256 times 256 times 256 would give us to the exact same place. I could open the calculator right now and figure it out, but it's a really, really big number. The truth is, you're never going to have a LAN that needs this many hosts on it. Let's get our network ID out of the way. A network ID for this is going to be the lowest possible value. The lowest possible value is going to start with 192, and then 8 zeros, and then 8 zeros, and then 8 zeros. So 192.0.0.0. Our broadcast ID for this is going to be not 192, and then all ones in the last 24 digits. So that one's going to be 192.255.255.255. And that creates a really, really large network.